Hi, my name is Bailey Chambliss, and this is my Physics 2212 Lab Number 2, Charged Lines. So the purpose of this lab is to produce a computational model of two charged tapes exerting an electric force on one another. Then use the model to estimate the amount of charge on each tape needed for one to float above the other. In my analysis, this experiment will distribute the charges evenly along the length of the tape rather than treating it as a point charge. We will then use a glow script computational model to show the charge across the line of tape. So in Lab 1, the tape indicated a positive charge because its tendency to repel other charged tapes and attract to negative objects. The values from Lab 2 differ slightly from Lab 1. In Lab number 1, we got that the charge was equal to 1.8 times 10 to the negative 8th coulombs, while in Lab number 2, it was 1.9 times 10 to the negative 3 coulombs. So our fundamental concepts and equations are Coulomb's law, electric field of a point charge, electric field of a rod, force of gravity, force and electric field, all with their equations given on the right. And then some concepts are the superposition and that the line charge is just treated as a collection of point charges. So the experimental design was the same setup as Lab 1, but treating the tapes as lines rather than points. So our assumptions are that air resistance is ignored, the tape is not a point charge, rather a line of charge, the charge is evenly distributed among the entirety of the tape, and the tape can be divided into segments, and the sum of these equal segments is equal to the total charge. So our initial conditions are that there are two pieces of tape approximately equal in length and neutral placed on a piece of neutral tape on a table. The length of the tape was approximately 0.2 meters, the width of the tape was 0.02 meters, and the distance between tape A and tape B was about 0.02 meters. So the experimental calculations shown to estimate the charge are shown. We assume that the net forces are equal to 0. The electric force is equal to the magnitude of the gravitational force. And then we went through and did the calculation, solved for Q, and found that Q was 1.9 times 10 to the negative third coulombs. So the glow script code is shown. It's a little messy, but starting on the bottom left, we add our initial constants, so all of our initial values. Then on the top, we have the code that goes through and finds the electric field. And then below that is just the equations that were given to find the line of charge. And then the bottom right is the electric force on the top tape due to the bottom tape and the net electric force and gravitational force. So our results and conclusions were that the tape was still attracted to a hand, the tape was still repelled by another piece of tape, and the tape was still attracted to a negatively charged pin. So, in conclusion, by treating the tape as a distributed charge rather than a point charge, the calculations for estimating the magnitude of the charge will still be more accurate. Some possible sources of error are handling of the tape during the experiment, inequality of charges on the two tapes, and incorrect assumptions. And then the photos on the left one is from Lab 2, and the right is from Lab 1. So the blue is the charge, so you can see in the left that we treated it as a line of charge, and then in the right it was just treated as a point charge. So the discussion questions. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got in your line charge model. So if this were the case, the results would have remained the same as in Lab 1. The only difference is in Lab 2 that we treated the tapes as line charges rather than point charges. So in the first lab, we got that the total charge was equal to 1.8 times 10 to the negative 8th coulombs, while in Lab 2, we got that it was 1.9 times 10 to the negative 3 coulombs. So there's a couple of degrees of difference in the labs. And then why do these estimates differ? Which value is more likely to be closer to the real value, and why? These estimates are different because treating the charge as a point versus a line has a different resultant level of precision. The smaller steps taken in the rod calculations lead to more accuracy, therefore it will likely be closer to the real value. Thank you.